Okay, so for today we are going to be talking about notes 13-1, which are going to be the measures of angles in degrees. We're also going to add radians in here a little bit, but we'll get to that in the end of this lesson. Okay, so to start out with, we're just going to review a little bit. We're going to talk about what angles are acute, obtuse, complementary, supplementary, what all of those different angles mean. So you should already know this, but acute angles are angles that are less than 90 degrees. Okay, this should be reviewed. You should definitely know this already. The next thing is going to be obtuse angles, which are going to be greater than 90 degrees. Okay, the next one is going to be right angles, which should be equal to 90 degrees. And the last one is going to be straight angles. Straight angles are equal to 180 degrees. All four of those are things that you should just know. You should have learned those a long time ago, and they should be something that you know right off the top of your head. Now, a couple of reminders from geometry. Complementary angles are angles that are going to add up to 90 degrees. Okay, so if you have an angle that is like 50 degrees and 40 degrees, those would be two complementary angles. Okay. Now, supplementary angles are going to be angles that add up to 180 degrees. Okay, so that one, if I had a 100-degree angle plus an 80-degree angle, those two would be supplementary angles. Okay, so all of that was just a review, just to get us started with what we are going for right now. Okay, the next thing that we're going to talk about is we're going to start talking about angles on an x and y axis or a coordinate plane. Okay, so an angle is said to be in standard position if its vertex is at the origin. Remember, the origin is just where the x and the y axis cross, and its initial side is on the positive x-axis. Okay, so all this is saying is its initial side is always going to be right here on this positive x-axis, and then what we call the terminal side, or where your angle ends up, is going to be anywhere in this other range, just where my angle ends. Okay, so the actual angle, theta, this little sign over here that we are talking about, is talking about this angle from your initial side to your terminal side. That's the degree measure that we're talking about. Okay, so 1 degree is going to be equal to 1/360th of a rotation. Okay, now we're going to talk about how we're going to rotate. So looking at this little picture on the left, it says a counterclockwise rotation represents a positive angle. Okay, so any angle that's rotating around in the positive or counterclockwise direction is going to be a positive angle. So let's think about this for a second. If you had a snowboarder who is snowboarding and they turned in a full circle, you would say that they did a 360. So what that's saying is, remember, this is our initial side. This is where we're starting out. That's saying if we went all the way around, all the way to this other side over here, that would be 360 degrees. Okay, so that also means if I only go halfway around, then this angle measure over here is going to be a 180-degree angle. We also talked about that a second ago when we talked about straight angles. Okay, so halfway around is 180. Now, what if we only went half of that 180? That's going to take me to 90. Okay, so each quarter of this little picture right here, this graph, is going to be 90 degrees. So I go from 0 to 90 to 180 to 270 and then 360, all in this counterclockwise direction. Okay, so anytime we're going in that direction, that's going to be my positive angles. Now, if I end up going clockwise in a clockwise rotation, now these become my negative angles. Okay, and this is something that you need to know. Counterclockwise is always positive, clockwise is always negative. Okay, so looking at this one, I'm still starting from my initial side right here, so this is where I start, but now I'm going in a clockwise direction. So I go from -0, or just 0, because 0 can't be negative, to -90, -180, -270, and then to -360. So all the numbers stay the same. The only thing that changes is now we're talking about negative angles instead of positive angles. Okay, so what we're going to do on these next few is we're going to sketch each of these angles. Okay, so we first notice on number 7 that this is a positive 30 degrees. So this tells me that I'm going to be going in a counterclockwise direction. I'm just going to write that down just so we know what that's talking about. We're starting at my initial side, which I know is 0. Okay, and then this one is going to be 90 degrees if I go straight up. This is going to be 180, and this is going to be 270. And if I went all the way around over here, this would be also 360. So 0 and 360 are always in the same place. Okay, I didn't say this a second ago, but those numbers right there, those are called your quadrantals because they're not actually in any of the 4 quadrants. They're the line that divides the 4 quadrants. So those are called quadrantals. Okay, so if you want to label those. Those are your quadrantals. Now, if I'm trying to draw a 30-degree angle, I know it has to go in quadrant 1 because it's between 0 and 90 degrees. Now, if I think about it, I don't want to take this 30-degree angle and put it right there because this right here is closer to the 90 than it is to the 0. Well, 30 is going to be closer to 0 than it's going to be to 90. So we want to draw that 30-degree angle down here closer to my original initial point. So this is my 30-degree angle that I created right there. Okay, so always make sure you can kind of tell where exactly it needs to go. If it's 30, it's closer to 0. If it would have been 60, then we could have put it closer to the 90. Okay, number 8, we're going to do the same thing. We're going to go through and label our quadrantals. We're still going in the positive direction, so this is going to be 0, 90, 180, 270, and 360. Okay, and we're going all the way to 225 degrees. So that means I'm still starting at this initial point right here, but I'm going around, and 225 is going to be somewhere over here in quadrant 3. Okay, go back and put your little angle like that so I can tell which direction we're rotating. And if you want to come right in here that this is a 225-degree angle, that helps us when we're grading things. Okay? So if you want to, just to practice, you can do this one by yourself, but I'm going to go ahead and go through it. We're going to start with 0 like we've been doing, still going in the positive direction, 90 degrees, 180 degrees, 270, and last but not least, 360. Okay, and this time we're going to 210. Is 210 going to be closer to 180 or 270? Think about that for a second. And you should have come up with 180. So my 210-degree angle is going to be a little bit closer to 180 than it is to 270. Okay, so not too bad. First things first, is it going positive or is it negative? And label those quadrantals. Now, if you look at number 10, you'll notice that you have a negative out in front of your 45. So that means now we're starting from our initial and we're going in a counterclockwise direction. Okay, so we're going to start with a 0 over here because 0 always stays in the same place. But now we're going around this way. So we're going to go, this is negative 90. This is negative 180. This is negative 270. And this is negative 360. Okay, so when I come up with my angle, I need a negative 45 degrees. Well, I know if it, to get all the way to my first quadrantal would be 90, then half of 90 is going to be 45. So this is going to have to go halfway in between right there. And we're going in the clockwise direction. So this is my negative 45-degree angle. Okay. Now, number 11 is also negative, so we're going the same direction we just did. So we're going to start with 0, and we're going to negative 90, negative 180, negative 270, and then back around to negative 360. Remember, we're still following that clockwise rotation because it's a negative angle. This one is going to be 135. If you did the math, you would find out that 135 is exactly in the middle of 90 and 180. So your angle right here is going to look just like that. And that's my negative 135-degree angle. Okay, just like we did on the last one, if you want to try this one by yourself, pause the video and then you can check yourself in just a second. So we're still in the negative direction. So we're going clockwise. We have 0 degrees, negative 90 degrees, negative 180 degrees, negative 270, and negative 360. Okay, and I'm going to negative 330 degrees. So 330 is going to be closer to 360 than it is to 270. So this angle going all the way around here is going to be my negative 330 degree angle. Okay, so just to wrap that up a little bit, always check, is it positive or negative? That tells you which direction to rotate in. And then go label your quadrantals. If you get a 30-degree angle up here like we did on number 7, do I need to label this 180 and the 270? No, you don't have to do that extra work on yourself. If you know that 30 is between 0 and 90, you can go ahead and label the 0 and the 90 and put the 30 in the middle. You don't have to do that extra work. Okay? Okay, moving on to this next part. This next part is we're going to start talking about what a radian measure is. In that last one, we talked about the degrees of an angle in a circle, which you should kind of understand because we've talked about angles and degrees before. Now we're going to be talking about radian measures. And a radian measure of an angle AOB is the number of radius units in the length of the arc AB. Okay, sounds confusing, but we're going to follow this formula right here that says theta is equal to the arc length divided by the radius. Okay, arc length is going to be represented by this S right here, and radius, which is the R, which makes it pretty easy because it starts with the radius, which is R. So looking at this picture, when I'm trying to find the arc length of my theta right here, it has S is this distance from here to here. That's the length of my arc inside of my angle that I'm talking about. And then R is my radius. So here's my radius right there. So to be able to find theta, all I have to do is take theta and do my S divided by my R to give me the radian measure of that angle. Okay, so if this says find theta in radians, first things first, we need to label which one is which. I know my 3 is along the outside over here. This is my arc length. So 3 is going to be my S, which means that the 2 belongs to my radius and is going to be my R. So I'm following this equation that says S divided by R, and we're just going to plug it in. So S was 3, R was 2. So my radian measure was 3 over 2. So theta is equal to 3 over 2. So the next one says if R is equal to S, find theta. So S, we know, is my arc length, and this one told me that S is equal to itself. So this arc length right here is the length S. Then it tells me that R is my radius, but up here it told me R is equal to S. So we're going to write that right here. So when I set up my equation, which is S over R, instead of plugging in the R, I'm going to take this S and I'm going to put it in place of that R. So we're going to end up with S over S. Well, we know if S over S is just equal to 1, right? Because if we had a 2 over 2, that reduces to 1. So the same thing happens with letters. So what this is telling me is that when my radius is the same length as the arc length that I'm talking about, then my radian measure is going to be equal to 1. So it says 1 radian is equal to the measure of a central angle whose arc has a length of R. Okay, so that's when R and S are the same length. Okay, now this next little box right here, we're going to practice converting from radians to degrees and from degrees to radians. So I want you to take your pen or your pencil or anything, whatever you're writing with right now, and I want you to put a box around this, put stars by it, do something, highlight it, something to tell, like to make this stand out for you. Okay, so we're converting between radians and degrees, and there are 2 equations that we're going to use. So if you're converting from degrees to radians, you're going to multiply by pi over 180. Okay, so you're going to use that little equation right there, and you're going to multiply by pi over 180. Now, if you're converting from radians to degrees, you're going to multiply by 180 over pi. Okay, so I want you to write under this, if you're converting from degrees to radians, you need your pi to end up in the top. So over here, write pi must end up in the numerator. Okay. Now, a little hint on radians to degrees. On this one, you want your pi needs to cancel. Okay, and those are just two little tricks that are going to help you be able to remember when to use which of those equations, because you're going to have to know when to use which one. Okay, so if I'm converting from radians, no, I'm converting to radians, and it wants me to leave in terms of pi. That means I don't get to use a calculator, that I want to just plug this straight in and be able to leave it in terms of pi. Okay, so from degrees to radians, we're going to multiply by pi over 180. So we're going to take this 225, we're going to put it over 1, and we're going to multiply that whole thing by pi over 180. Okay, when I do that, I'm multiplying straight across. So this becomes 225 pi divided by 180. Now, we don't want to leave this as a giant fraction like that. We want to reduce and be able to simplify this. So if I divided both of these by 5, 225 is going to be 45 pi, and if I divide 180 by 5, 5 goes into 18 3 times, and I'd have 30 left over, so 30 divided by 5 is 6. Now, that's still not as far down as I can reduce that, because 45 and 36 can both be divided by 9, so if I reduce again, that's going to give me 5 pi over 4. Okay, so the degree measure of 225 degrees is the same thing as the radian measure, 5 pi over 4. Okay, so now we're going to do the same thing on this next one. We have 330 degrees, and I'm trying to convert it to radians. So I know on all of my radians, I want the pi to end up in the top. So I know I have to multiply by pi over 180. If I multiply straight across, I would get 330 pi over 180. Now, I don't know about you, but the easiest thing for me to do on this is say I have 2 zeros, so if I reduce by 10, those zeros are going to cancel out, and I'm going to have 33 pi over 18, and then 33 and 18 are both divisible by 3, so if I reduce, I would get 11 pi over 6. Okay, so this one is saying that 330 degrees is equal to the radian measure 11 pi over 6. Okay, if you want to try the next one by yourself, you can. The negative doesn't change anything. It means your answer has to be negative. So we're still multiplying by pi over 180, which means I have negative 60 pi over 180. Okay, same thing happens with the zeros that it did the last time. So this tells me I have negative 6 pi over 18. Negative 6 and 18 are both divisible by 6, so I get negative pi over 3. Okay, so negative 60 degrees is the same radian measurement as negative pi over 3. Okay, so that was converting from degrees to radians. Remember, to go from degrees to radians, you always want the pi to end up in the top. Now, what we're going to do is we're going to convert to degrees. So our little hint over here was that the pi's need to cancel. Okay, so if my pi needs to cancel, I have to put another pi down on the bottom so that it cancels. So I need to remember, when I'm going from radians to degrees, I'm going to multiply by 180 over pi so that my pi's go away, which gives me 180 divided by 3, which is going to be 60 degrees. Okay, so 60 degrees is equal to the same thing as pi over 3. Didn't we just say that? The only thing that was different on this last one was that the 60 was negative. So the only thing that changes if you add a negative is just the sign of it. Nothing else changes. Okay? Okay, doing the same thing with number 7. We want the pi's to cancel, so we're going to multiply by 180 over pi. So my pi's are going to cancel and they're going to go away. Now, if I take that 3 and I multiply it by the 180, that's going to give me a really big number. So I'm going to see if I can reduce first. So I'm going to take this 4 and the 180, and both of those are divisible by 4. So if I take 4 and I divide it by 4, I get 1. If I take 180 and divide it by 4, I get 45. Okay, so if I have 3 times 45 on the top, that's going to be 135 degrees. Okay, if you're getting to use a calculator, which we should let you use the 4 function ones, you don't have to reduce first. You can multiply straight across, and then you would get 3 times 180 divided by 4, which is 540 divided by 4, which would just give you 135 degrees. So you can do it either way. If you have a calculator, you're welcome to do it the bottom way that I just wrote that. Okay, number 8. Same thing, we still want the pi's to cancel. So we're going to multiply by 180 divided by pi. So my pi's go away. On this one, 6 will go into itself 1 time and will go into 180 30 times. So now on top I have 11 times 30, which is going to be 330 degrees. Okay, so remember these 2 little rules. If you're going from degrees to radians, you want the pi to end up in the numerator. So you need your pi on top, which is why we multiply with the pi on the top. If you're going from radians to degrees, we want our pi's to cancel, so we have to have this pi on the bottom to cancel out with the one that's on the top. Okay, that's just a quick little hint to remember those. Okay. Okay, now here's something I mentioned earlier. If the terminal side of an angle lies along an axis, the angle is called a quadrantal angle. That's what I was talking about earlier. So all of these quadrantals from degrees, we should already know. Remember, this one is 0 degrees. This one is 90 degrees. This is 180. And this is 270. And then this last one is 360 degrees. Okay, so those are my quadrantals. These are something that you have to know. You should be able to spout those off. If I ask anyone in this room, everyone should know what those are. Okay, to find the radian measures, we're going to take what we just did and we're going to convert each one of those quadrantals into radians. Okay, so easiest one first, 0. If I take 0 and I multiply it by something, I'm just going to end up with 0. So this is going to be 0 just like it is on the other one. The next one, we need to do the 90-degree angle. So this is going to be 90 degrees. And to get it into radians, I want my pi to end up on top. So this is going to be pi over 180, which gives me 90 pi over 180, which reduces to pi over 2. If you want to put the 1 right there, you can put the 1 right there. So that means this radian measure is going to be pi over 2, which is the same thing as 1/2 pi. Okay? So now the next one we want to do is we want to convert 180 into radians. So we're going to multiply by pi over 180 to give me that pi on the top. If I multiply straight across, I get 180 pi divided by 180, which reduces to, those cancel out, and we're left with pi. So this radian measure over here is pi. Okay, now I have to do the same thing for the 270 at the bottom. So 270 over 1 times pi over 180, because I want my pi on top. It's going to be 270 pi over 180. If you reduce those by dividing by 90, you're going to get 3 pi over 2. So this radian measure over here is 3 pi over 2. Okay, then the last one that we want to do is we want to do 360. So we're going to do 360 over 1 times pi over 180, which gives me 360 pi over 180, I want to reduce that. So that's going to be 360 divided by 180, which is going to be 2 pi. So my total distance around that circle is going to be 2 pi. Okay, I don't know if you remember this or not, but the equation, now we'll talk about that later. Don't worry about that. Okay, so those are my radian measures that equal my degree measures that we talked about over here. So what we're going to do now is we're going to take these and we're going to graph this radian measure just like we graphed those degree measures earlier. But we're not going to put in all the work to be able to convert it to degrees and then graph it from there. We're going to use the radian measures that we found for our quadrantals over here to be able to figure this out. So let's think about it this way. If I know this is pi, and I'm trying to come up with the quadrantals for this one, what I want you to think about is an actual pi. We're going to start with 0 right here because we always start with 0. So go ahead and put your 0. Now, if I need a pie that has 6 slices in it to get from here, sorry, you got to follow me on the mouse, to get from here all the way over to this, that's a full pie. So if I think of a full pie that's cut into 6 slices, this is going to be 6 pi over 6, because that's just telling me how many slices are in this whole pie, okay? So if I know that's 6 pi over 6, well, if I came over here and I went all the way around the circle, all the way around the circle is 2 pi. So if I had 2 pies that were cut into slices of 6 on each one, to have 2 full pies would give me 12 pi over 6, because I would have 12 slices in my 2 pies that are cut into 6s. Okay, so now let's look at this next one. I need half of a pie. So if over here, I know a full pie is 6 over 6, half of that pie would give me 3 pi over 6. Okay, so if I have 3 pi over 6, this one down here, this last quadrantal that we haven't done yet, that is 3 pi over 2, or 3 halves pi. So if I have 1/2 is equal to 3, remember that's what we said up here, 1/2 is equal to 3, I need 3 of them. So 3 plus 3 plus 3 would give me 9 pi over 6. Okay? So those are my quadrantals that are based off of turning it into being able to graph this specific radian measure that needs a denominator of 6. Okay, I just took my original quadrantals up here and I turned them into fractions that had a 6 in the denominator. Okay, so now if I'm going to be able to graph 5 pi over 6, I know it's going to be somewhere in between this 3 and this 5. Well, 5 is closer, 3 and this 6, well, 5 is closer to 6, so the 5 pi over 6 is going to be somewhere over in here. Okay, so it starts at my initial side and it goes over to where it runs into my terminal side, and that is 5 pi over 6. Okay, I know this sounds like a lot. It will get much easier the more that we practice it. Okay, so looking at number 10, this one, I have 5 pi over 4. So I need to think of this one in terms of fourths instead of in terms of 6s. So we're always going to start with a 0. And then remember, looking up here, my quadrantal that's in the 180 spot is pi. Okay, so for a full pi, from 0 to pi, this one needs to be in fourths. So this is going to be 4 pi over 4. Because if I took a pie and I cut it into 4 slices, a full pie would have 4 slices in it. Okay, now just like we did in the last time, now I need one that has 2 pi up here. Okay, so 2 full pies with each of them cut into 4 slices would give me 8 pi over 4. Okay, and then the next one is going to be, I need half of a pie. Well, if my pie has 4 slices in it, half of it would be 2 pi over 4. Okay, and then this last one down here is going to be 3 halves. So I need 1/2 gives me 2. So 2 plus 2 plus 2 is going to be 6 pi over 4. So now I have my quadrantals, now I can graph my angle. Remember, you're starting at your initial side over here, so this is where I'm starting out. And I'm going in a counterclockwise direction. So it's going to be greater than 4 pi. So it's bigger than this one, but smaller than this one. So it's going to go right in between. So I have this angle, which is 5 pi over 4. Okay, hopefully this is starting to make a little bit more sense. Okay, number 11. This time I need it in terms of thirds. Okay, so always start with your 0. Now we're going to come over here, and I need this to be a full pi. So if I need it to cut into thirds, this has to be 3 pi over 3. Okay, and then over here, if I'm finishing this one, this needs to be 2 full pi. So this is going to be 6 pi over 3. Now, in between, I remember this has to be half pi. So I need to take half of this number right here. So half of 3 is going to be 1.5 pi over 3. And then if I need 3 halves to get this one down here, 1.5 plus 1.5 gives me 3, plus another 1.5 is going to give me 4.5 pi over 3. Okay, so to be able to graph this, all I have to do is I need 2 pi over 3. Well, this is 1.5 and this is 3. So 2 pi over 3 has to be somewhere in here. Okay, and you see a little bit closer to the 1.5 because 2 is closer to 1.5 than it is to 3. Okay, and then this last one right here, they were nice to us because they put it in fourths again. So we can just look at what we got for our other one. However, this one is negative. So by making it negative, remember we're going in a counterclockwise direction now. So this one we have to start with 0. And then we're going to go to negative 2 pi over 4, negative 4 pi over 4, and negative 6 pi over 4. Okay, so if I'm graphing negative pi over 4, that's only 1 pi because there's a little 1 out here that we don't write. So it has to be between these two right here. Okay, and then last thing I want to talk about is we need to talk a little bit more about like what a radian is, okay, and why we write it like this. So radian measures this 0, 2 pi, pi over 2, pi, and 3 pi over 2. Those are just decimals. Okay, right, pi right here, remember that's the decimal 3.14159, and it goes on forever and ever and ever. So instead of writing this decimal, we write it as a pi sign. Okay, this right here is if I took pi, 3.14159.265, and on, and I divided it by 2, I get 1.5 something. Okay, so this is about 1.5. The reason we just don't write this is because there would be a bunch of decimal places that would go right here that would make it confusing. So we just write it as a pi over 2 because that's easier to remember. Okay, so overall we talked about a lot today. You're going to need to practice these on your homework, especially number 9 through 12, to make sure that you understand them. I would highly recommend that you practice them by yourself. Do not just look at the notes. See y'all in class tomorrow.